Good morning, dear students. Welcome back to physics class. On today, I introduce second experiment of the gravitation chapter, which is determination of the density of solid, which is denser than water, by using spring balance and a measuring cylinder. Aim for the experiment is to determine the density of given solid, which is denser than water, by using a spring balance and a measuring cylinder. Let me see the theory part. The mass of a unit volume of a substance is called its density. That is, density of an object is ratio of mass of the object to its volume. Now, I think it's the time you have to be known a new concept. It is nothing but it is the relative density. As it is very important subject as far as concerned to the densities of substances. What is relative density? Relative density of a substance is defined as the ratio between the density of the substance to the density of water at 4 degrees Celsius. Why should be selected the density of water as reference value? Because density of water is 1 gram per cubic centimeter at 4 degrees Celsius. Here, the temperature must be 4 degrees Celsius as water has maximum density at 4 degrees Celsius. It has no unit, that is, it is a pure number. It tells how many times a substance is heavier than water. Relative density of a substance can be calculated by dividing density of a substance with the density of water. For example, density of iron is 8500 kg per meter cube. You know that density of water is 1 gram per centimeter cube. When it converted into corresponding SI unit, it will be equal to 1000 kg per meter cube. So, the relative density of iron is equal to 8500 divided by 1000. It is equal to 8.5. It has no unit. Density of a substance can be calculated by multiplying relative density of the substance with the density of water. Since relative density is equal to density of the substance divided by density of water at 4 degrees Celsius. So, density of a substance is equal to relative density of a substance multiplied by density of water. What are the materials required for this experiment? A spring balance, a stone, a cotton thread, a measuring cylinder, a glass beaker, tap water, an iron stand, etc. What is procedure? First, find the zero error and least count of the spring balance. Take an iron stand and suspend a spring balance to it. Study the spring balance, its scale and its least count. Record your observations. If any error, record it as X gram weight or X gram force. Next, you have to calculate the mass of the solid by measuring the weight of it by using a spring balance. Take the stone, tie it with a thin strong thread, hang it on the hook of the spring balance. It is better to hang the spring balance with the help of an iron stand or clamp stand so that it remains static while taking the readings. Carefully observe the gravitational mass of the solid and note it down. Repeat it tries and calculate the mean value of the 3 readings taken. Now we need to find the mass of the stone. You have to note this point. Mass of an object m is equal to its weight divided by acceleration due to gravity, that is W by G, as W is equal to mg. Now let me think how to find the volume of the stone. For this, take a graduate glass cylinder of proper size and capacity. Fill it with water up to a known volume level mark. Try to immerse the tied stone fully in water taken in a graduated cylinder by means of the thin strong thread. The stone displaces water and the water level rises. Note the position of water level or meniscus, keeping the eye in horizontal position with the level. While doing so, it can minimize the error due to parallax. What is parallax error? How does it happen? It is one kind of personal errors which occurs due to human carelessness. For example, if you by habit always hold your head a bit too far to the right while taking the position of a needle on the scale, it will cause an error, which is due to the parallax. So, this error is called parallax error. For example, if you by habit always hold your head a bit too far to the right while taking the position of a needle on the scale, it will cause an error due to the parallax. This error is called the parallax error. You know that error means uncertainty which affects to the result or in producing absolute result. Instead of taking the right reading, which is 60 centimeter, he can read it as 68 centimeter because of the parallax error. On next, you have to find the difference of two positions of the water level to find volume of the stone immersed. That is the difference between two levels. First one, the initial position of the water level in the measuring jar, and second one is final position, which is after the immersion of the stone in water taken in the measuring jar. Repeat it twice and calculate the mean of 3 observations taken. This slide gives two tables. First table for the measurement of mass of the solid block, it is the stone, and second one for the measurement of volume of the stone, V. This slide shows observation and calculation. First, for the zero error in spring balance. Here, the spring balance has no error, that is, it is non-zero error. So, it will be equal to 0 gram weight. That is, the error which is called zero error is equal to 0 gram weight or 0 gram force. On next, you have to see the least count of the spring balance. It is noticed that 5 divisions correspond to 25 gram weight. Then what should be the smallest division? 1 division is equal to 25 gram weight divided by 5, which is equal to 5 gram weight or 5 gram force, which is the smallest measurement which can be made accurately with the help of the spring balance. And you have to tabulate the mass of the solid, which is in gram, and mean value of volume of the solid block, which is the stone, V, which should be in unit of centimeter cube. After, you have to calculate the density of the stone, which is mass divided by volume, which should be tabulated in unit of gram per centimeter cube. Again, you should mention the result, which is the density of the given solid, which is heavier than water, in unit of gram per centimeter cube while you are writing the practical record. Students, you should notice this point that what are the precautions to be taken for this experiment. First point is always use a thread of least weight and volume to tie the solid block. Second point is the solid block should be tried before measuring mass and volume. Third point is the indicator of the spring balance should be at 0 before measuring the mass of the solid. Fourth point is the solid block should be completely immersed in water of the measuring cylinder before observing its volume. Fifth point is while immersing the solid block, the water of the measuring cylinder should not spill. Sixth point is the solid block should not touch the brim and sides of the beaker. And seventh point is always note the reading of lower meniscus of water level. Dear students, today I am giving you some experimental viva questions. Kindly please, you have to practice these questions. Okay, thank you. Have a nice day.